All right, kids, this is going to be a quick one. This is chapter 10, section 2. It's going to be on area of circles and regular polygons. I know that you know the area of a circle. It is pi r squared. Yay. The area of a circle is the number pi times the radius squared. I want to talk about why that is. And I think I've done this in class already. I'm going to imagine this circle like it's an orange. I've been eating a lot of oranges off school lunches lately. So imagine this circle is an orange with a whole bunch of slices. If I were a good drawer, I would have drawn those slices right in the middle, but I didn't. Oh well. Imagine if I took this orange and I peeled it in half. So I broke it open. That would give me a bunch of slices doing this. Let's do one more. And another set of slices doing this. If I took this set of slices and I flipped them over and I inserted them in here, we would get a shape that looked kind of like this. Because there'd be 5 slices on top and 5 slices on the bottom. And this shape is essentially a parallelogram, right? It's basically a parallelogram. If I made way more slices, these little curves get much flatter. There'd just be a bunch of little curves here and a bunch of little curves here, and the parallelogram would look way rectangular. Well, this height right here is the radius, right? Like one of these strands here is going to match one of these strands here. So this height is the radius. And this length right here is half of the circumference. Circumference means distance all the way around. We know the circumference of a circle is 2 pi r. Well, if this length right here is half the circumference, that's half of 2 pi r, which is just pi times r. So if I find the area of this rectangle, it's r times pi r, which is pi r squared. So here's the area of a circle and the perimeter of a circle. Area is filling in the circle. Circumference is the perimeter walking around the circle. Pi r squared and 2 pi r. The other one we're going to do is called a regular polygon. Now, I trust you remember that a regular polygon has sides that are... Boy, I don't know what's happening here. Well, that didn't make it regular. I really thought that it would. Sides that are all the same length, which means angles that are all the same length. That's so interesting. Okay, I'm going to try to make this regular. One cool way, no, whatever. Okay, I'm going to show you a trick for how you can make things kind of regular-y. One thing you could do is draw a circle. And if I move along this circle, what does this thing do? Good. That's going to be as regular as I'm going to get. It isn't actually regular, but it's as close as I'm going to get. I'm going to find the area of that pentagon inside that circle. Stop it. I'll find the center of the circle. Do that in size 6. Find the center of the circle, which is going to be the center of this pentagon also. Because this is regular, I can think of it as being 5 of the same triangles all smushed together. 5 congruent triangles forming this pentagon. So if I can find the area of one triangle, I can just multiply it by 5 to get the area of this pentagon. Well, the way you find the area of a triangle is base times height. So I'm going to find this height right here. This height has a special term. It's called an apothem. An apothem is the distance from the center of a shape. We'll just call it a regular shape in this case. Center of a regular polygon to one of the sides. Okay, that's what an apothem is. So any of these could all be apothems. Sounds like opossums, but it's not. So if I take this apothem, which I'm now going to call A, and say that I find the length of this base B, 1/2 times A times B is the area of this triangle. Now there are 5 of those triangles. So if I do 1/2 times A times B times 5, that gives me the area of the pentagon. But this has another kind of weird application. See, there's 5 sides to this pentagon, obviously, all of which have length B, which means the perimeter of this pentagon is 5B. So when I do 1/2 times A times B times 5, B times 5 is actually the perimeter of the pentagon. So I could take the area and turn it into this. 1/2 times the length of the apothem times the length of the perimeter. And your book is going to write this as 1/2 times A times P, where A is the apothem and B is the, or P, capital P, is the perimeter. I'm sorry that I'm writing so poorly. So, for example, let's pretend this is a regular shape with center here. This is a hexagon. Has 6 sides. If the apothem's length right here is, let's say, 6, and this side over here is 10, then the area of this shape would be 1/2 times the perimeter, or times the height, times the apothem, which is 6. So I'm doing this formula. Area equals 1/2 times A times P. Well, the apothem length is 6. The perimeter is 60, because there's 6 lengths of 10. So 1/2 times 6 times 60 is 180 units squared. Okay, so we have 3 formulas we talked about. 1/2 times A times P for polygons. Pi r squared for circles. And 2 pi r for the circumference of a circle. That's it for today. See you next time.